Good morning, friends and dear students. It gives me immense pleasure to be here again for my favorite course, Aircraft Systems. Today, I am in the process of definition and terminology related to the module 3 of Aircraft Systems. This course belongs to the 6th semester of Aeronautical Engineering student from Institute of Aeronautical Engineering, Hyderabad. Today's the topic is aircraft hydraulic and the pneumatic system. As you know, I am Dr. Dwivedhi, professor from Institute of Aeronautical Engineering, Hyderabad, India. As of now, I have completed my 56th lecture and this is my 57th lecture. I have completed module 1, which comprises of aircraft structural system or airframe system, and also it gives about introduction of aircraft vehicle system, avionics system and mission system. If you talk about the module 2 covers aircraft electrical system, power distribution system, power control system, power conversion system, and also air conditioning and environmental control system. Today I am in the module 3 and this module 3 covers aircraft hydraulic and the pneumatic system, which I have already covered in my previous classes during module 3 cover up from I think lecture number 9 to 16 or 17. Today I am going to discuss about the definitions, some special terminology which are related to the aircraft hydraulic and the pneumatic system. So as of now I have covered all the topics. However, I will be discussing about only a short notes on the aircraft hydraulic system and the pneumatic system. In today's topic I am going to take about topics and the course outcome mapping, and in this you can see that today I am going to map most of the time CO3, course objective of the CO3, fluid characteristics and the properties CO3, types of hydraulic fluids also CO3, typical hydraulic system and the component, accumulator, pneumatic system and the component of the pneumatic system. So first I am going to discuss about what are the hydraulic fluids used in aircraft. So the fluids used in aircraft hydraulic system is one of the system's most important parts. So which type of fluid we have to use and the characteristics of the fluids are very much essential, and as the engineer or the maintenance engineer of this hydraulic system or airframe system which is related to the hydraulic systems like landing gear, door opening, your control opening, your all the primary, secondary like elevator, aileron, rudder, flaps, slats, spoilers, these all things has to be operated by the help of the hydraulic system. And if we talk about the hydraulic system and the control system should be very much accurate, means the how much the aircraft is need to turn, how much it has to go nose up or the nose down or anything, correspond to that only our control should move. So if the hydraulic fluid which we are using is not proper, it will behave erratically. So some of the characteristics that must be considered for this thing is viscosity, then chemical stability, flash point and the fire point. These are the 4 very important characteristics of aircraft hydraulic fluids, and this I am going to discuss in due course of time in the next few slides. So first thing is define viscosity. Okay, so what is the viscosity? Viscosity is the internal resistance to flow. If suppose this is the pipe and this is the hydraulic fluid here, this fluid has to move in this direction. So there will be a resistance from the wall and this fluid. This resistance is called viscosity. Okay, so viscosity is the internal resistance to the flow. So the fluid will, each layer of the fluid will have the different, it will rub and it will give some frictional point or frictional properties. So it is an internal resistance to flow. Gasoline flows easily, has a low viscosity. Tar flows slowly, as a high viscosity. If we compare between water and the gasoline, gasoline will have less viscosity because it flows very easily. If you see about the water, it will flow slowly, and if you take the grease, if you take the tar which is used for the road repair and all, they are very, very slow, and so because the viscosity is very high comparing to the gasoline. A satisfactory liquid for a hydraulic system must have enough body to give a good seal at pumps, valves and the pistons, but it must not be so thick that it offers excessive resistance to flow. So we should also have something that fluid should not be very thick, otherwise it will not flow. So we should have a proper amount of viscosity, so that it should give the lubrication, it should give the cooling, and same time it should flow easily. The average hydraulic liquid has a low viscosity. Most of the hydraulic liquid which we are using have the less viscosity. Define chemical stability. So next definition is about the chemical stability. So chemical stability is the ability of the liquid to resist oxidation and deterioration for long period. So once we talk about the chemical stability, this stability indicates that it should be able to resist the oxidation. Means if it is mixing with the oxygen of the atmosphere, it should not form its oxides. Second thing, the deterioration of the quality should be maintained. The different molecules of different parameters should not separate. It should behave as a unity. Excessive temperature have a great effect on the life of the liquid. So the temperature makes the chemical stability problem. Liquid may break down if exposed to air, water, salt or other impurities. So the liquid which we use normally in hydraulic fluid, each particle of this liquid may separate if it is exposed to air or water or the salt, or if other impurities like sand or dust is mixed, the liquid proportion will be able to change. So we have to ensure that the chemical stability of the hydraulic fluid is maintained at all the high temperature as well as in the low temperature. So because when the pump is working, the temperature of the fluid will be increasing. Sometimes the ambient temperature is very high, it may go to 50 degree or 54, 55 degree sometimes. So aircraft can operate at very high temperature also, and also they can operate at a very low temperature. So the fluid which we are using, it should be chemically stable in all type of operating environmental condition. That must we have to ensure. Now if we talk about the next characteristic is flash point. So the flash point is the temperature at which a liquid gives off vapor in sufficient quantity to ignite momentarily when a flame is applied. Okay, so flash point, if you take the petrol or the gasoline and if you keep it in a atmospheric condition, it evaporates, and if the evaporation is so much huge that a small amount of flame can make it to burn. But if you take the tar, if you take a high density liquid and if you put the matchbox and put it here, burning, it will not burn. But if you put the burning matchstick on the gasoline, it will burn, because lot of vapors are already accumulated and these vapors gives the firing very easily. So the flash point is the temperature at which a liquid gives off vapor in sufficient quantity to ignite momentarily when a flame is applied. So if sufficient amount of vapor is produced on top of the fluid, then we should be very careful, because a small amount of ignition or spark may explode it. Your fluid may be burning and it will be like explosion. So we need a high flash point is desirable for hydraulic fluid. So we cannot use the gasoline, because if in high pressure it will evaporate, and with a little temperature it will start burning. So a high flash point is needed for the hydraulic system or hydraulic fluids. Next is define fire point. Fire point is the temperature at which a substance gives off vapor in sufficient quantity to ignite and continue to burn when exposed to a spark or the flame. So there is a small difference between the flash point. In flash point, it may not be continue burning, but a burn will take place, and after that it may stop or it may propagate. But if you talk about the fire point, the vapors are so much accumulated that if you give a spark, it will continue burning till the time whole fluid is not burned. If you talk about the hydraulic system, the fire point, a high fire point is required for desirable high hydraulic fluids. So we need a high fire point to get the desirable conditions. Now, how many types of hydraulic fluids are there? We can divide this hydraulic fluids in the three groups. One is the vegetable base, another is the mineral base, and next one is the synthetic fluids. So vegetable base means it is from the natural trees, like our mustard oil or some seed oils or some castor oil and all. They are coming from the vegetables. Another are the mineral oil, and third one is the synthetic, which is made by mixing some different parameters. And minerals it is extracted from the ground, like your diesel and petrol. They are form the mineral oil. So define mineral based fluid. So how we can define the mineral based fluid? So they are defined with some military standard. Military H5606 is the most widely used hydraulic fluid in general aviation aircraft. Kerosene type petroleum product, dyed red for identification. So this is military H5606. This is red in color, mostly used for aircraft hydraulic system. It is another name is OM15. It is also used, and I think this is the equivalent to this OM15, oil mineral 15. They are made in red in color so that we can identify that it is a hydraulic fluid. If we talk about the synthetic fluid, they are the non-petroleum based hydraulic fluids for use in high performance piston engine and turbine powered aircraft. Most commonly used fluid of this type is Skydrol. The name of the most important which is used for this aircrafts, especially the piston engine and the turbo engine aircraft, we use this Skydrol, and it is in light purple, colored with light purple, so you can identify. And they are the non-petroleum product. They are made with the different mixtures and used in the high performance piston engine and the turbine powered aircraft. These things are used. Now, if I want to demonstrate about a typical hydraulic system, so a typical hydraulic system consists of a reservoir, and then here it is a filler cap, then it will go here, then it will go to the pump. This is the pump. From the pump here, it is the valve. This valve will open or the close. So the hydraulic yellow is the hydraulic fluid supply, and here is the hydraulic pressure. The red color is the hydraulic pressure, and then it will go to the cylinder, and it is a single acting cylinder. So one way it will press it, and another way it will go by this way. It is a return line. Okay, so here is the return line. So in this way, and this is the selector valve. This selector valve will open and close. If it is want to go from here to here, this will close here, and if this has to go, so it will operate and this will close from here. In this way, your selector valves are working. It is a very simple idea of the hydraulic system. Then I have to say about how many components are there in hydraulic system. So normally we have some very important, I have here shown nearly the 7 components are here. They are the reservoir, they are the pumps, they are the selector valves, they are the check valves, they are the hydraulic fuses, they are the accumulators, they are the actuators. So these are the some very important component of the hydraulic system. So now, what is the reservoir? If you see here in this diagram, so this is called the reservoir, a tank where the hydraulic fluid is stored. So that is called the reservoir. So in an inline reservoir, space is provided in the reservoir for fluid expansion and the escape of entrapped air. So in the reservoir, it is stored, fluid is stored. Also, space is provided in the reservoir for fluid expansion. If the temperature is high, it can expand, and if the temperature is low, it can contract. Also, if air is trapped, there is a vent line. In this, the air is removed. Jet aircrafts that operate at altitude where there is not enough air pressure to assure a positive feed of the fluid to the pump have hydraulic reservoir pressurized. So if the high altitude and high performance aircraft, they go for high altitude, so their reservoir also to be pressurized, because it will not go by its own. The gravity may not work up to the pump. So a pressurization, a positive pressure is required, so that a continuous feed of the hydraulic fluid is there up to the hydraulic pump, and from there hydraulic pump will take over and it will supply for the further operations. So next, it is here I am showing you here the hydraulic reservoir pressurized by hydraulic pressure. So just now I told you that if it is a high performance aircraft, we need to pressurize the tank or reservoir. I will just write the reservoir. And how to pressurize? It is a schematic is shown here. So here we have one piston here in the reservoir. This is the piston here. So here high pressure from the system, and here is the fluid. So it will try to pressurize here. So this will be pressurized, and the high pressure will enter from here, and the low pressure from here. So it is a filler, and it is the output. Output high pressure, and this is the vent line which is used for this purpose. So now define pumps for hydraulic systems. So one is the constant displacement pump. So in this we have the gear pump, generator pump, and the vane pump. So they are the constant displacement pump. These pumps are used to pressurize the system. Pumps, they increase from lower pressure to upper pressure, or low pressure to high pressure. They are able to generate. And we have different types of pumps like gear pumps, generator pumps, and the vane pumps. I am going to discuss one by one in this next slides. First one is the defined pump. We have the powered pump, that is called the constant displacement, moves a specific volume of the fluid each time its shaft turns. Variable displacement does not move a constant amount of fluid each revolution, but only the amount the system will accept. That much it is accepting. If you see about the gear pumps, so here we have medium volume of the fluid. In the gear pumps, some gears are only used, and these gears are operated in the opposite direction. So here if you see, the inlet is coming from here, and this goes to the spaces here, and due to this spaces it is trapped and the pressure is generated. So outlet is here. If it is the more pressure, it will be going and it will be operating. It is a continuous type of gear, and here also if it is more than the required quantity, it will come here. So generator pump, the generator pump, we have the rotors here, driven rotor, and here is the drive gears. They are operating, and if you see here, from here it is trapped and it is inlet here, and here is the outlet. Then it is rotated, then it is going here, and at the last it is the high pressure is obtained due to its different shape, and your fluid is trapped. So if you see here, from here to here, this much area, this much area, this much area, this much area, and this much area. So this lobes make it pressurized. Another is the vane type. So here we have inlet here. From this side we have the inlet, and here we have the sleeve. We have the spacer here. We have the vanes. These vanes are shifting, and if you can see here, this area is very less, and here we have the very high area. So this much high area will enter here, and this will move from here high to volume is reduced. If the volume is reduced, then pressure is increased, and in this way, after this increased pressure will move from here to here. This is the outlet. This is the inlet here. So at inlet you have the more area volume, and as it is passing, the volume is slowly it is reducing, and as the volume is reduced, the pressure is increased. So this is a very simple principle of and it is some eccentric rotors are here, and by this it is operating. So now next I am going to discuss about name the valves used in hydraulic systems. So we have some selector valves, we have some sequence valve, we have some priority valve, and we have some pressure control valves. These all valves I am going to discuss in my slide. So define plug type selector valve. So what is the plug type? Here one plug is there. That plug will start moving, and accordingly your space will open or the close. So this you can see here, it is here now, but as and when it is moving, the location of this has changed to this. So this side it will close, and this side it is open. So like this, as it is moving, it will open or close the valve, and a free space will be here, and it will go from here to here. And if it is here and it is blocking here, fluid will not go from here. So illustration of the popper type selector valve. So here also another selector valve is here. It is called the popper type. The red color is the pressure line. So this line is coming from here, and it is going from here to here, and then it is supplying here, and from here it will go to here, and this will open, and the return line is from this side, it will be return. Same way here also a different location is here. If it is the left and the right, here is the left and the right. Here the right side is pressurized, gear up, and here is the gear down. So it is a fluid moving the piston to the left, here fluid is moving the piston to the right. So here it is pressurized from here, so it is moving in this direction and it is moving in this direction. So like this, these popper valves are operated, and this green is here the return line and the red is the pressure line. Operation of the sequence valve. So we know that we have the sequence valve, and if you see in our aircraft, the sequence should be operated. What is the meaning? Suppose it is the landing gear. So landing gear, to open the landing gear, if it is inside, to open the landing gear, first the cover or doors should be open. So this operation, the sequence valve, first they will operate the doors. First door will open, then only it will start moving. So it is so arranged that as and when this extended and the retracted well door actuator, so first the door will actuate and then only your landing gear is going to operate. So here if you see about priority valve, so priority valves are there is a insufficient pressure to open the valve and there is a no flow of fluid through it. So if the pressure is not sufficient, 1, 2 and 3, these all valves are closed and there is no pressure. The pressure is sufficient to hold the valve open and there is a flow through the valve. So if this pressure is sufficient, it will press the spring and the fluid will go from here. Now fluid flow through the priority valve in the return direction. Now if you see, if it is the priority valve and the sequence will be in opposite direction. So accordingly it will work and the sequence will be operated as per the required system. So hydraulic fuses, you know that in electrical we have the electrical fuse. As and when the power is high or there is any short circuit or there is any disturbance in the electric current, fuse will burn. Or nowadays we have the circuit breaker, this circuit breaker will start falling. Same way in our hydraulic system also we have the fuses. The purpose of the fuses is to cut off the power supply whenever this system is abnormal. So flow is stopped, the pressure drop across the fuse has moved the piston over so that it covers the holes through which the fluid must flow. So if you see here that in this case this piston is here, so it is going from here to here. But if you see in the normal flow, if the pressure is not sufficient, this will close this hole, so flow will not go. And yes, so this piston is such design that at sufficient pressure it will be here, as and when the pressure is not sufficient it will start moving in this direction, it will close as it is shown here. So this is called the hydraulic fuses. These hydraulic fuses are for the safety purpose. The system should get the required amount of pressure, then only it will work. Next very important component is accumulator. So if you talk about the accumulator, these accumulators are accumulating or storing the fluid at a high pressure. They are operated with the help of the nitrogen or the air. High pressure air or the nitrogen is filled. This high pressure nitrogen, there is separator between these two, and below that there will be the hydraulic fluid. So the main purpose of this accumulator is to accumulate the excess energy if it is not used by the system. As and when the system energy is getting lower than that pressure, it will supply the pressure for emergency use. Also it absorbs the fluctuation of the system, and smooth functioning of the system is performed by the help of accumulator. So all accumulators consist of a high strength container divided by some form of movable partition into two section or compartment. One compartment connected to the hydraulic pressure manifold and the other is filled with compressed air with nitrogen. So I think it is there, yeah. So here this, you can see the accumulators. Here we have the accumulators, here the system pressure. Here air or the nitrogen is charged here. So this nitrogen will enter in this zone. Here is the nitrogen or the air. Here is also nitrogen or air. The high pressure HP air, nitrogen used, maybe 3000 psi, some 100 bars is pressurized. From the top, the hydraulic fluid is charged. Here this hydraulic fluid is filled. So this is such a way that there is a membrane between this. These are the membrane in such a way that if this pressure is high, the hydraulic pressure is high, it will lift here, it will move on this side, and as and when this hydraulic pressure is lower than this will push. So this will start pressing like this. So as and when you require in the system, it will go. So here another type of fluid inlet is from here. There is a piston and there is a air valve. This is a second type and this is the first type of accumulator here we have. So now in hydraulic system actuator, it is the last component of any system where we can see that your control surfaces like elevator, aileron and the rudder, these all are operated by the help of the hydraulic fluids. This hydraulic fluid has to be pressurized by hydraulic system and these actuators are 100% required to operate and their feedback should be correct. So here this we can see here, we have here one the single acting actuator and another is the double acting actuator. So actuators are devices which can turn from linear single acting linear motion, it can convert or it can go make to the rotary motion. It can be the double acting unbalanced linear, single acting linear and double acting balanced linear. So here two type of actuators are shown here. Single acting linear actuator for the brakes. So here this you can see that a spring is here, a spring will pressurize this thing. As and when you give some pressure, it will move this direction and this will operate the brake system here. And here we have the double acting. So in this both side, up port and the down port. So like this is upward and this is the downward and it is acting in the both direction, but in this only one port is there. So it can operate in the both the way, but it will operate only one direction. That is this type of actuators are working in this way. Now the next part I am starting now, the pneumatic system. As we know that as and when all the main operations are done by the help of the hydraulic system, all the actuators are mostly working with the hydraulic system, but in case some of the actuators are not working, that time our pneumatic system comes into the play. The pneumatic systems means the air or the nitrogens are used. Mostly we use the air system and we have seen that in the pneumatic system, lot of our instruments, especially the inertial instruments are working like gyros, your attitude indicator, your heading indicator, the suction gyros. These things are operated by the help of your vacuum system. So sometimes the pneumatic system is also called the vacuum pressure system. Aircraft pneumatic system, power instruments, landing gears, flaps, air conditioning, windows, doors and more. So here we can use it. This aircraft pneumatic systems can be used for our instrument panel, like it is shown here. Our gyros are there, attitude indicators are here, and all these equipments are also operated. Landing gears also, if your hydraulic system is not operating, our landing gear has to be operated by the help of the pneumatic system. Flaps also, air conditioning and the windows, doors and the more. Our doors are also operated, your opening and the closing of the passenger doors are also operated by help of this pneumatic system. In a small and the light aircraft, suction pressure gauges shows vacuum system pressure. So these are used. If you see here, here we have the pump. Here we have the pump. Then we have the relief valve, vacuum air filter, suction gauge, gyros, instrument and attitude indicators are shown here in this diagram. So here we can see that equipment used here, pneumatic equipment used pneumatic in small aircraft. Okay, so here we have the gyro compass, we have the artificial horizon, and we have the turn indicator. These are shown here. What is the filter? The filter is the equipment which extract any type of impurities which is not good for the pneumatic system. If you are not able to extract and the pollutants are entering, they will start damaging the pumps, they will start damaging the pipeline, they will start damaging the valves. So the system accuracy will be reduced, and after some time, due to the wear and the tear of the system, pump may break, pipe may crack, and these all things may happen. So it is very much advisable that in the given time the filters to be cleaned, filter to be opened, and proper maintenance and the replacement of the filter as per the given lifetime, it has to be performed. So pneumatic air filters are shown here. Prevent system from the contamination, remove air particulates. Clean air is essential to good operation. So clean air is required to make this thing working. Next is the pressure regulators. The pressure regulators are the devices which regulate the pressure and give the required amount of pressure, and if that much pressure is they are providing, so safety of this thing also ensured by the pressure regulator. Pneumatic pressure regulator prevents system overpressurization and ensures proper calibration. These are the two main functions of the pressure regulator. So it prevents overpressurization. If it is overpressurization, the pipe may burst, your system may collapse, and lot of damage may happen. So it will not allow to give more pressure than the designed required pressure. Ensures the calibration. Your system should be calibrated as per the requirement. Now, if you see the air pumps, like hydraulic pumps, we should also have the air pumps. These pumps can be sucked, then it is called the vacuum pump, and if they are giving the pressure, it is called the pressure pump. So they are the heart of the pneumatic system. Is pressure or vacuum air pump, usually engine driven. Two basic types of pumps are here. One is wet pump, wet air pump, use engine oil to lubricate pump internally. Next is the dry air pump, more common, have graphite veins inside pump casing, self lubricated as pump rotates. So there is a wet air pump, in that the lubrication engine oil is coming and it is lubricated and it is coming. But in the second type of, it is a dry pump, your pumps are made by the graphite veins. Graphite itself is a lubricating property and it will work and it will self rotate the system. Here we have one very known pneumatic system of the operation, and this you can see here that how these operations are done. So here we have the pump. This pump is here. It is suction type of the pump. It is rotated. The air is sucked from here. Then it goes to the heading indicator. Then it goes to the attitude indicator. And here is the suction gauge. It will indicate that how much suction pressure is generated. Then it will revert here. It will go to the vacuum regulator. From here the regulated pressure is obtained, and then it will go to the exit. This is the exit. So in this way a simple system is shown here, and if any health issues are there and there is going to be some problem, a flag will be coming out and one warning light will come here in this instrument. So we can find out that there is going to be some problem, not the problem but going to some problem. So we have to take the corrective action before it is really failed. So filtered air is pulled through system by vacuum pump. Evacuated air passes through instrument case, causes gyro to spin. Spinning gyros provide rigidity in space for instrument reference. Air exhaust through gyro pressure gauge exhaust port. Gauge pressure, system pressure, failure warning systems. So these are the few things which are working with respect to that. So I have ended this lecture here, and my references are here. I have taken the 2 references which are recommended books for the aircraft systems. The first book is Moyer I and the Seabridge, Aircraft Systems, Mechanical, Electrical and Avionics Systems, Subsystem. This is from the Professional Engineering publication. Another book is again from the Moyer and the Seabridge, Design and Development of Aircraft Systems and Introduction, AIAA Education Series, AIA 2004. Any questions I will surely like to have. You can comment in the comment box of this video. Thank you very much for the joining, and please be tuned for my next lecture, and thank you for this.
Like, share and subscribe. Hit the bell icon for more updates.